Yeah, so good evening, everyone. This is our fourth session, and we'll be discussing APGP.
Can you rename me? This is Sahil.
Neha, this. Yeah, so this is our fourth session, and we'll be discussing APGP. So that AP is a short form for arithmetic progression, and GP is a short form for geometric progression. So I don't want to rush to the things. If we can finish up neatly arithmetic progression, we'll do that today. And we'll continue with GP tomorrow. Tomorrow will be our last session for this workshop. Okay, so before starting with definition, example, etc., let me start with a story which is relevant to AP. So we are starting with the discussion of AP, and I'll start with the story of great mathematician Carl Friedrich Gauss. I think we have mentioned this name earlier in some session. He was a German mathematician, and his period was 1777 to 1855. So almost about 240 to 250 years back was there. Yeah. So in fact, he was a child prodigy right from his early stage. He was very good at mathematics, and there is a story which is well documented that when he was 3 years old, I don't know what maths we did at the age of 3 years, but when he was 3 years old, he found a mistake in his father's account. So he could not just add, subtract, multiply, etc., but he could do long additions, and he found some mistake in his father's accounts. Yeah, so we are going to see here a story when he was about 6 to 7 years old. So maybe in first standard or second standard.
Hello, sir.
Yes.
I'm late by 3 minutes. Could you tell me what you're doing today?
So we are doing APGP, arithmetic progression, geometric progression, and I haven't started with the topic yet. I'm starting with a story of German mathematician Carl Gauss, which is relevant to AP or related to AP. Yeah, so the story is as follows. So he was in first standard or maybe second standard, and their teacher gave them the following addition: 1 plus 2 plus 3 plus 4 plus 5 up to add numbers up to 100. So 99, 100. And teacher thought that they are small kids.
Third.
Yeah.
Folded the numbers.
Yes, so let's see. Yeah. So teacher thought that perhaps they are small kids and they'll take more time to add all these 100 numbers, and thought that he'll get some rest. But to his surprise, in fact, little Gauss, he did it this way. So that is, so Gauss found the answer in about 1 minute, and Gauss technique was followed. So you see, numbers are very much structured. They are consecutive numbers. If I go 1 up, the difference is 1, and if I go 1 below, difference is minus 1. So if I go to the right side, numbers get increased by 1, and if I go to left side, numbers get decreased by 1. So that, in fact, so if I add first and the last number, how much is that? 101. If I add second and the second last number, you see again the sum turns out to be same. Why? Because from 1 to 2 we take one extra number, and from 100 to 99 we go down by 1, right? So essentially the sum remains the same. Then 3 plus what will be number before 99?
98.
98. So again you see that sum is also 101, and these are total 100 numbers, and Gauss was pairing two numbers together, first and the last, second and the second last, third and the third last, and so on.
So there will be 50 pairs of them.
Yeah, very good. So 100 numbers equal 50 pairs. So there were 50 pairs, each giving sum equal to 101. And therefore the answer to the question was 101 plus 101 plus 101. How many times? 50 times, right?
It is equal to 5,000.
So it's essentially, repeated addition is essentially multiplication. It's 101 into 50, and all of we can calculate, that is 5050, right? So that's the story of Gauss, and of course this was.
So this formula n into n plus 1 by 2, so can I prove it in a one more way?
Yeah, we'll prove it today.
No, like what different way? Not this way. So it's very easy. So can I share?
Yeah, we will do that. Huh? So I'll show it in a different way, and if you have a still different way, you can tell me that, right?
Okay, sir.
Yeah. So that's the story of Gauss when he was 6 years old. Let me say a little more things about Gauss. In fact, he was very fast and very good at mathematics. So at the age of 19, he completed his, at the age of 19, he completed his master's degree. What are MSc, MA, whatever. So I think that time there was a MA degree. So anyway, he completed his master's at the age of 19, and he completed his PhD at the age of 22 years. Let me tell you, like as far as today's trends are concerned. So for example, in my case, I completed my BSc at the age of 20 years, so bachelor's degree, then MSc at the age of 22 years. And if at all you want to do PhD, master's. So 2 more years for master's degree, and later on, as far as latest trends are concerned, you need to read about 2 to 3 years for your PhD, and then again further 2 years at least for your work. So just a minute. So about 5 years for PhD, and therefore by the time you finish your PhD, you are at least 27 in today's world. Okay, so he was at least 5 years faster than us. Yes, somebody was saying something.
So will those questions come in the Olympiad?
No, actually, see, Olympiads are totally, so there is no repetition of question, and every Olympiad contains totally fresh stock of questions.
Okay.
So essentially, as far as Olympiad preparation is concerned, you should be good at the theory part or conceptual part, and you should solve a lot of problems on your own.
Okay, sir.
Yeah, so that's the one prepares for Olympiad. But there is no repetition of questions, or not even repetition of type.
Yes, sir.
Yeah. Okay, so Gauss finished his PhD at the age of 22 years, and that's a famous theorem in algebra. That was his PhD thesis, fundamental theorem of algebra. And later on, at the age of 24, he wrote a very path-breaking book. And when he was 24 years old, he wrote a book that's a Latin name. I don't know exact pronunciation. Disquisitions. Arithmetica. It's a Latin name, and essentially it stands for investigations in arithmetics. Arithmetic, algebra, number theory, various topics. In fact, later on, throughout his career, Gauss worked on various topics like algebra. Essentially, that book contains some fundamental ideas in number theory like congruence, reciprocity laws, etc. Then he worked in physics, astronomy. In fact, Gauss was the head of observatory at Göttingen. Astronomy, complex analysis, which was comparatively a new topic in those days. So René Descartes was the first one who worked on complex analysis. Next, Euler worked on complex numbers, and Gauss was one great mathematician who worked on complex analysis. And he also worked in geometry. In fact, what we would learn is geometry by Euclid, or that's called as Euclidean geometry. But Gauss did his own geometry, and such geometries which are not done by Euclid in his book Elements, they are called as non-Euclidean geometries. So he worked on non-Euclidean geometry. That's about the work of Gauss. So rightly he was called as Prince of Mathematics. So he did a lot of work in mathematics. I don't know why he's called as Prince, but if at all we want to say King of Mathematics, Euler was King of Mathematics. Okay, so coming back to our example, we are interested right now in the sums of the form 1 plus 2 plus 3 plus 4 up to some n. And we saw one technique by Gauss, which essentially says that you add first and the last, second and the second last, third and the third last, and all these sums remain same or equal, and therefore this answer turns out to be essentially n plus 1, n plus 1. How many times? N by 2 times, right? Because if your number is 100, there are 50 pairs. If your number is n, and let's assume for the time being it's even, then there are n by 2 pairs. So that's Gauss technique. But we'll look at this sum in a little different way. We will try to prove this formula. What is 1 plus 2 plus 1 up to n? And anyways, remember that though that story is famous by name of Gauss because of his age, so it happened at the age of 6. But much before Gauss, this was known to Indians as well as Chinese mathematicians. For example, Aryabhatta from India.
Ramanujan.
But Ramanujan is comparatively a recent case. Ramanujan's period is 1889 to 1920.
Oh, okay.
But So even Ramanujan was very much later to Gauss, but Aryabhatta, Brahmagupta, Bhaskaracharya, they were all from.
So Brahmagupta was a mathematician.
Yes, yes. And in those days, by scientists, they meant, so they were philosophers, mathematicians, astronomers, etc., etc. So,
Sir,
like multi-talented. Yes.
Brahmagupta as in the king of Magadha. No, the
No, he was not king. He was a mathematician. But I don't know whether he was in Magadha's kingdom.
okay.
But he was a mathematician. He was not a king. So, yes. So, Aryabhatta in his book Aryabhatiya mentioned formulas for 1 plus 2 plus so on up to n, 1 square, 2 square, 2 up to n square, and 1 cube, 2 cube, 3 cube up to n cube. So right now we are dealing with the first one, 1 plus 2 plus 3 plus so on up to n. And let's do the proof of this. So suppose I call this sum as S. S for sum, let S equal to 1 plus 2 plus 3 plus so on up to n. What will be one number before n?
N minus 1.
Very good, yeah. Then one number before that will be n minus 2 and so on, right? Now, suppose if I want to write some 1 plus 2 plus 3 plus 4, can I write this as also 4 plus 3 plus 2 plus 1? Is it right?
Yes, sir.
I'm changing the order. Instead of writing from left to right, I'm writing from right to left. And this property of addition is called as commutative.
So the commutative,
Yes.
sir.
Yes.
So the commutative property.
Yes.
Commutative property.
Yes, yes. So we say addition is commutative. Even multiplication is commutative. But for example, A minus B is not same as B.
And subtraction is not.
So subtraction is not commutative. Or A divided by B.
Sir, it is commutative in addition because A plus B equal to B plus C as 1 plus 2 equal to 2 plus 1.
Yeah. So subtraction, division, they are not commutative operations, but addition is commutative. So you can flip the things or you can change the order. Fine?
Yes.
Yes. So shall I write? Yes. So shall I write same sum also from this side, and I'll write it as n plus n minus 1 plus n minus 2 and so on up to lastly 2 and 1. All of you agree?
Yes, sir.
Yeah. So now we'll add these two equations. What we'll get on left hand side? Such things we have done in that first day puzzles. So S plus S. What is S plus S?
2s. Sir, 2s.
2S. Very good. Yeah. So 2S is equal to, now I'm going to add vertically. So I'll add this way. 1 and n. 2 and n minus 1. Essentially that was that Gauss idea. Then 3 and n minus 2. Lastly, n minus 1 and 2 and n and 1. So now you go.
N minus 1 is equal to 2 as therefore S equals to n into n plus 1 whole by 2.
Yeah. So this plus this is how much? That is n plus 1, right? So first answer is n plus 1. What is second answer? That is again n plus 1. Check. What is third answer? That is again n plus 1. Right? and so on up to last. Now, how many the n plus ones we get in this case? I'm not pairing with one and the same row. So essentially, I have got 1
Get n plus 1 sums.
to n. So there are n terms, and therefore I get n plus 1, n plus 1. How many times? N times, right? And repeated addition is essentially multiplication. So this is n times. So I get 2 times s is equal to n into n plus 1. All of you agree with that?
Yes, sir.
So how much is s? Like for example, suppose I say 2 times s is 100. How much is s?
Sir, it is 50.
Yes. So how do we do that?
Sir, because 100 by
So what you do is 100
Sir,
by
if there are 50 numbers, we should pair it up into 25 and 25.
No, I'm not talking of pairing in this case. So I'm just talking of equation. Like suppose 2s is 100. How much is s? S is 100,
100 divided by 2.
right? 100 by 2. So 2 times s is n into n plus 1. So how much is s?
50.
No, I'm talking of this equation. So what do we do?
2 is equal to, s equal to n by 2 plus n plus 2.
Yeah, very good. So what do we do? Divide, right? So 2, which is for multiplication on this side. If I take it to this side, it's for division. So s is n into n plus 1 by 2. And that's our formula for sum of n numbers. Okay, so go through it.
So can I see now my proof?
Hi. Is it different than this?
Yes, sir.
Just a minute. So let people see this and we'll go to next page.
Which sir, but what about 1 square plus 2 square and then 1 cube plus 2 cube?
Yeah, that's a nice question. So there are some other methods even for this sum also.
Okay.
I'll go to next page and talk about that. Huh?
So
It's a nice question.
I don't understand.
So my proof, sir, I can say
Just a minute. Huh? Somebody had some doubt.
So me,
Who is that?
Sahil.
Yes.
Sir, I forgot the meaning of s. Like let s is equal to.
Okay, so that sum of 1, 2, 3 up to n, whatever answer that turns out to be, I'm calling that as s. So let's.
So s is sum.
It's generally S stands for sum. You take it any name. So like for example, A, B, C, D, anything, A to Z, anything. But generally, I mean, because it is sum, I use this. Yeah, so far good, all of you?
yes, sir.
No, sir, I'm reading it.
So we have got a formula now for addition of first n numbers. And that will be useful even further while finding the sums in AP.
Done, sir.
Okay. So my proof, sir, can I say like it's like this, but it's like a visual proof. It's like this, but it's visual.
Okay. Who is that, Saket?
The Saket.
Yeah, go on, say.
So it's very like similar, but it's like more of visual. So first let's pick like one, and like it'll work for everything, but let's just pick one to make it simple, like 5. Okay.
Hmm.
So now just draw like 1 dot in the first line, two dots like a right triangle, like 1 dot and then 1 dot below it and the second dot in the right and then 3 dots like that. So just draw.
Okay, yeah. Or instead of dot, are rectangles fine?
Yeah.
Yeah.
Star,
So,
rectangle,
okay,
anything.
so Saket is explaining another proof with example n equal to say 5.
5.
Okay, yeah. this one. Yeah. So you draw a rectangle which is 5 cross 6. 1, 2, 3, 4, 5. Two, 3, 4, 5. And now I have to draw 6 vertical columns. Yeah, so 1.
Yes, like that.
Okay, so what we have done is we have drawn one rectangle of size 5 cross 6. But more generally, I mean, whatever we are.
Sir, when n is equal to 5, you put the 5 blocks in the vertical, and due to the n plus 1, you put 6 on
Yeah.
the horizontal line, or
Yes,
there is
very good.
something else behind it.
Yeah, very good. So more generally, when there are n rows, I'll draw n plus 1 columns. One more than that. Okay. And now I'll divide the whole figure as follows.
Sir, only Dona side. I was gonna say that, but
So can you see yellow lines?
Yes, sir.
Yes, sir.
Yes, sir.
We are counting 5 blocks.
Yeah. And now you see so there are 2 parts of the rectangle. And what is area of this part? 1 plus 2 plus 3 plus 4 plus 5.
5. Sir, but area is about multiplying, right?
So we are taking those lines to be unit lines. So length breadth is 1 1.
Okay.
So area of one part is 1 plus 2 plus 3 plus 4 plus 5. That is area of one part. And therefore area of 2 parts is 2 times. So you see again, it's same for the second part. 1, 2, 3, 4, 5. Right? So total area is 2 times 1 plus 2 plus 3 plus 4 plus 5. If I divide it into 2 parts, but as a whole, the rectangle has area 5 into 6. So more generally, if I use instead of 5 and 6, n plus 1, what it gives is 2 times 1 plus 2 plus 3 plus 1 up to n is equal to n into n plus 1. Okay, so 1 plus 2 plus 3 plus 1 up to n is equal to n into n plus 1 divided by 2. In fact, geometric ideas are always nice and easy to understand for school children. So this is better proof.
sir, I didn't say anything only.
Yeah, in fact, there are many proofs. So, for example, I know 5 different proofs of the same.
Sir, why are we doing 5 into 6?
No, he said just as an example, as a demonstration. So, I mean, n is abstract number. So, rather than calling, so what should I take as n? So I have to take some number just
Yes.
to depict the diagram. So he took it as n equal to 5.
Okay. No, so I'm not understanding why are we doing it 5 into 6?
Because it's n into
Because 6
n
is
by
1
n plus
plus
1.
5.
N plus 1 is 5 plus 1. 5 plus 1 is 6.
Yeah, so
Right.
see that in fact this is a proof after one knows the actual answer. So the same answer, so because we know now it's n into n plus 1 by 2. Now just to demonstrate it geometrically, so they have taken it 5 into the next number 6.
Yes, sir.
Okay, should we go ahead?
Yes, sir.
So let me write once again the formula.
Which is so can you explain 1 square plus 2 square plus 3?
So these are all unit squares. So what is unit square? Length, breadth are 1. So you find out area of this part. So there are two parts. Do you see? And they are equal in nature. Fine. They are identical figures. If I lift one side, rotate it, I can put it over this other part, and they'll match with each other perfectly. Right. So area of one part is 1, 2, 3, 4 plus 5. So area of one part is 1 plus 2 plus 3 plus 4 plus 5. Similarly, area of other part is same 1 plus 2 plus 3 plus 4 plus 5. So total area is 2 times of 1 plus 2 plus 3 plus 4 plus 5. And also total area is same as 5 into 6 because it's a rectangle of sides 5 and 6. So this typical idea is called as two-way counting. So you count the same area in two different ways. Essentially, all equations, equalities are always, or identities are always examples of two-way counting. Yeah. So,
Sir,
uh,
sir, for the formula of 1 square plus 2 square plus 3 square, so like this visual proofs, so I just thought, is this correct? And so
there,
the formula for 1 square plus 2 square, so on till n square will be
see, let me tell you
n
the idea.
multiplied.
Let me tell you the idea. So here for 1 plus 2 plus n, we are focusing on area, which is two-dimensional. Now, if you are talking of 1 square, 2 square, up to n square, essentially you should talk of volume. 3D diagrams.
So isn't that cube, not square?
No, for 1, 2, 3 up to n, you need to focus on area. Okay, so for 1 square, 2 square, n square, you need to focus on volume.
Then what about 3 square? See 3, part by 3.
So for cube, there is no geometric proof as such.
Okay.
Because it will be some dimension for equivalent of area and volume.
Sir,
And we can't see 4D.
Can I have an idea? For 1 square plus 2 square plus 3 square, so on till n square.
Right now we won't go into that because
No,
that
no, so it's just like this, just one step. So the formula which I think it is, which I'm not sure, is
no,
n
I
into
mean,
n plus 1.
why we are not focusing on that, because it's not related to AP. So right now our focus will be on AP. Okay.
sir,
Yes.
sir, 1 plus 2 plus 3 plus dash dash plus n is the area, and 1 square plus 2 square plus dash 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 equal to the volume. Sir, then if we find the area and if we
That is what we did.
square the area, can we find the volume?
Area into one more side, like height, will be volume. So there you have to deal with cubes.
No, sir, so not necessarily. So it's very simple. So n into n plus 1 multiplied by n into n plus 1 whole plus 1 whole thing divided by 2. So that's my idea. So can I explain why?
No, but what is the formula for 1 square, 2 square, n square?
So I'm not sure like the actual formula. Mine is not simplified or anything. It's just n into n plus
Formula is
this thing, n into n plus 1 multiplied by n into n plus 1 whole divided by 2. So that's my idea, what I think.
This is the formula. N plus 1 to n plus 1 plus. Are you getting that with your idea?
No, so can you just check what mine is? What I'm doing is like same way I'm like putting 1 and then putting 2 and then putting 3 on the first on the length, and on the width I'm putting n, and that when you multiply that, what will come, it will like divide by 2, so that will be my answer.
No. Actual answer is this one. That is what I'm saying. It's not by 2, it's by 6. Yeah, anyways, we won't go into those details because that is not related to AP. So I started with 1 plus 2 plus n because we need that in AP. Yeah, so once again, we have formula in general for n numbers, where n could be anything. Even if I put n equal to 100, let's put n equal to 100 for that Gauss story. And let's check his answer. So if I put n equal to 100, then LHS is 1 plus 2 plus 3 plus 1 up to 100. And RHS will be 100 into 101 divided by 2. That is 50 into 101, which is Gauss answer, right?
500. Huh? Oh, 5,000.
Right? Yeah.
Yes, sir.
Okay. So now let's solve some simple problems based on either formula or Gauss technique first and the last, or what are your own technique. Anyway, geometric, whatever the way you want to work. Let's see some simple problems. So these are not typically Olympiad type problems, just to make clear your concepts. You can work anyways, either by formula or you can use the Gauss technique, that is first and the last, second and the second last, whenever possible. Or what are your own way. That's always best. Whenever possible, try to devise your own ways. That's best. Okay, so I'll write some questions, and as usual, you can write answers in chat box, but write answers to me. Don't disclose the answers for everyone. Is that okay?
Yes, sir.
Yeah. And please remember, Olympiad is no race, like I'm first, I'm second, and so on. So main point is write correct answers, think properly. Don't rush to the answers. As I said once,
That means the Olympiad is on Saturday.
we said it.
This Saturday, right? Because you said the Olympiad is in 2 days.
What I said was, or what I meant was, don't rush for the answers because Olympiad is not some race.
Oh, okay.
Yeah. So it's not like I'm first, somebody second, and so on. So the main point in Olympiad is you should think properly, skillfully, logically, and you should write answers.
Okay, sir. God.
Ref, send the answer.
Just a minute. Let me complete the questions and I'll check the answers. Yeah, this is something interesting. You get nice patterns there. All odd numbers. These are all multiples of pi. Okay, so write answers in chat box. I see there are so many answers already.
Sir, I'm writing all my answers in one and sending it. So I've already gotten 3.
Okay, no problem. Yeah, if somebody's answer is wrong, if I see, then only I'll mention it. That check the calculation. Otherwise, you assume that your answer is correct. Pranath Kumar Sudarshan, just check your calculation.
So for which question?
That first one,
First,
or have you said it later again? Have you sent later again? Shreyank Pawar, check your second answer.
Okay, sir.
And I think you have got a double answer. So you have to divide by 2.
Sir, all my answers are sent. So please check.
Just a minute. Yes, Saket. Saket, just check third one. Maybe it's a typing mistake error here, or maybe some calculation error. Yeah, so rest everything is fine for all of you.
Wait, so one part which is wrong. So sorry, wait 1 minute.
Sir, is mine correct?
Sir, my answer correct.
This guy?
Sir, Aitareya.
Yeah.
Good.
I tell you, only thing I did not understand that big answer, some 5,000 something, which was,
Sir,
it is that one.
So third one I again sent. So please check.
sir, which one didn't you understand? Which
Somewhere you had written some 5,000 something.
So it's the
5250. Sir, it is 5250.
So
Okay.
that is for which sum?
Sir, can you repeat?
wait. So the third one. So I resent. So please check.
Just a minute.
Sir, I sent you my answer, sir, margin.
Sir, my number is 5250.
For which one? For which one?
Sir, for fourth one.
Fourth one. Okay. I think.
Wait. So please check.
perhaps-
So the last one. So please check.
Yeah, just a minute. I think there is some calculation mistake.
Sir, in
Sir,
which one?
Saket,
Saket, now it's correct. Yeah.
which is
Sir,
which is 5 is correct. No, all 5 is correct, right?
Yes.
Sir, Arjun, can you check my answers?
Arjun, yes, all are correct.
Okay.
Sir, the 52501 is wrong, right?
Perhaps. I don't know. I don't have answer. But just a minute. That is perhaps wrong. Yeah, 5250 is wrong. Okay, so I'll start working now.
Sir, 1 minute, sir. What?
Sir, is my all answers correct?
Who is that? Aitreya?
Chirayu.
Chirayu, yes, yeah. Okay, so for first one, we have formula, or as well as you can do it by Gauss technique. So 1 plus 2 plus 3 plus so on up to 20. And if I put in the formula n equal to 20, I'll get the answer. What is the formula?
N into n plus 2.
So 20 into 20 plus 1
Sir,
by
n
2.
into n
By
plus
2.
1 by
By
2.
Yeah, just a minute. 1 plus 2 plus n is n into n plus 1 divided by 2. So I'm putting n equal to 20. The answer is 20 into 20 plus 1 by 2. All of you agree?
Equal to
That
10 into 21 equal
That is
to
2 and
10 into 21. Just put 0. Yeah.
Or
Sir,
yes,
sir, am I Aitreya? Sir, is
Yes.
my answer correct now?
just a minute. I think some 1050 or something.
1050.
For fourth one, na?
Yes, sir.
Okay, so there is one more way. What we can do is first and the last, second and the second last, right? And all these sums will turn out to be equal, namely equal to 21 check. And there are 20 numbers. 20 numbers is how many pairs?
So 10 pairs.
Very good. Yeah. So 10 pairs. And there are 10 pairs.
That is where 20 divided by 2 comes in.
Yeah, so 21 added 10 times. So that is 21 into 10. So this is 210. Fine with first problem? Shall we go for second? Two, 4, 6, 8 up to 20. And you see, one sure technique is that Gauss technique 2 plus 20, 22, 4 plus 18, 22, 6 plus 16, 22. And now how many numbers are these? Be careful. How many numbers? They are all even numbers up to 20.
So 10.
Number.
Very good.
It's very simple. So it's just so no. So that's a you don't have to do. It's a Ganesh is my method.
Just a minute. Let me show different ways. And if you have some
Sir,
different ways,
sir,
then
even numbers are because even numbers can be found out by skipping every two numbers. So
Exactly.
we can divide the 20 by 2 and we get 10 numbers.
exactly, yeah. So out of 20, 10 numbers are even, 10 numbers are odd. And we are right now taking even numbers. So there are 10 numbers. And 10 numbers equal to how many pairs?
5 pairs, sir.
5 pairs. So
Five.
each pair giving 22, and there are 5 pairs. So 22 into 5, 110.
110.
Okay. I'll show by one more way. And if somebody has some different technique, you can tell me afterwards later.
So this is Gauss's method, right?
Yeah.
So my method, sir, can I share, sir, please, sir?
Just a minute. Let me show one by one more way. And then if you have some third way, you can tell. Okay, so 2 plus 4 plus 6 plus 8 up to 20. Now what one can do is take 2 common because all are even numbers.
So it's 22 again, right?
So 2 ones are 2, 2 twos are 4. Where 22?
Because 20 plus 2.
So this is my
22.
method, sir. So this is my method.
Okay, yeah. So do you see if I take 2 common, it's 2 into 1 plus 2 plus 3 plus up to 10, right? I can take 2 common from every number because all of them are multiples of 2. They are
Yes,
even numbers. And we know formula for 1 plus 2 plus up to 10. So shall I
Yes.
say directly 10 into 11 by 2, right? So these 2 and 2 cancel. And therefore it's 10 into 11. So 110. Yeah. Anybody has any different technique, any different method?
So right.
So it's the same technique which I was about to say.
Okay.
So
Huh?
I use the other method, the one which Gauss used, Gauss's method.
Okay. So the top one, first and the last, second and the second last.
So third question, sir, can I explain on strategy, sir, please?
Yes. So what is third one?
3 plus 1 plus 3 plus 5 plus 7, so on till plus 21. So
Yeah.
can I share this one?
Yes. Just a minute. I'll write down. Okay. So we are solving now third one. Up to 21. So these are now odd numbers.
So I know the method.
11. Yes, sir. Sir.
How is that?
So Saket, sir. So that,
Hold on.
yeah. My technique is, so now, so to each term, so there are 11 terms, right?
Yes. Why 11? Yeah. Nice. How many terms are they? These?
1, 3, 5, 7, 9. So from 1 to 10 there are 5. From 10 to 20 there are 5. From and 21, so 11. So
Very good. Very good.
so now what you can do, just add 1 to each, okay?
Very
So
good.
now we simplified it to 2 plus 4 plus 6, so on till 22. Okay, now that whole thing you have to minus 11.
Right.
Which, so just write it down, no? So
Or shall I
So, okay, fine. So it's fine. Okay, it's fine. Don't let it.
No,
Okay.
shall I do a little bit different?
No,
But
no,
essentially your
it's
technique
better,
only.
very easy also. So just that 2 plus 4 plus 6 so on till 22 is 1 plus 2 plus 3 so on till 11 multiplied by 2. Now the
Yeah.
whole thing you minus 11.
Yes,
So
11, yeah.
20 divided by 2, which is 1 plus 2 plus 3 so on till 11, which is equal to 66. So now 66 we multiplied by 2 because it's 2 plus 4 plus 6.
Yeah.
That will be 102. Now subtract 11 from that, you'll get 121.
Very good. Yeah.
Or one other
Or
simple method.
let me show you your technique only with little easy modification. So for example, I'll write 1 as 1 and 3 I'll write as 1 plus 2. So now I don't have to subtract something. I'm breaking those numbers. 5 I break as 1 plus 4. 7 I break as 1 plus 6 and so on. Up to 19 I break as 1 plus 18. 20 I break as 1 plus 20. And you see, these are 11 111s. And this answer already we have found. 2 plus 4 plus 1 up to 20, right? So this is 11 plus that answer. That answer is 110. This we have already worked. Is it okay?
Yes, sir. Wait, yes.
Because already we have worked that problem. Just check. So this was 110, right? So why unnecessary work again? Already we have worked this. So 11.
So basically, you just took that minus and directly added that itself. So it's the same thing only.
Yeah. So instead of so in your technique, you have to add 111. So you have to subtract again 111. And here I don't have to separately subtract. I'm breaking those numbers into 1 plus even, 1 plus even.
Yes, sir. Okay.
Okay. Or you can use Gauss technique, first and the last, third and the second last, and so on. That's another way. Or in this case, at least, look at some nice patterns. And in maths, many times patterns give you some hint like what should be in general answer. So for example, 1 I write as 1. 1 plus 3 is 4. 1 plus 3 plus 5 is
Yeah, so
9.
the answer is n square. Yeah,
Yeah.
so that
So
formula
these are
forgot.
all squares, right?
So then 16. So we have to write the numbers according
Can I explain why, sir?
1, 2, 3, 4, and then just write it square.
Say it again.
Where's it?
No, sir. So, for example, 1, 2, 3, 4 we are writing. So we just have to write it square. For example, 1 square 1 and 2 square 2. So, for example, next 4 square we have to write 16 and 5 square 25.
Right. So more generally, sum of first and odd numbers. Sum of first and odd numbers turns out to be n square. That's
Wait, sir. So can I
But-
prove this, sir?
actually we won't prove it, but we'll see it geometrically.
No, because it's very easy to prove. So it's just like
Yeah.
it'll take
Yeah.
2 seconds.
But right now we won't prove it. I'll show a nice geometric pattern of squares. 1, 1 plus 3. I'm adding 3 now. 1, 2, 3. Plus 5. 1, 2, 3, 4, 5.
Oh wow! Oh
Plus
yeah.
7. 1, 2, 3, 4, 5, 6, and 7. So you see, you get squares. Okay. So these numbers are squares. Basically, numbers have geometry attached with them, and so these are square numbers. Okay. But similarly, you can have triangular numbers, pentagonal numbers, hexagonal numbers, and so on. So I'll go to next page and talk about triangular numbers. So 1 plus 2 plus 3, this is essentially Gauss sum, plus 4. So all these numbers are triangular numbers. So when I say 1 plus 2 plus 1 up to n, this is nth triangular number. Okay. Nth triangular number. So that is n into n plus 1 by. So it's 1, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, and so on. So these are triangular numbers. Similarly, so you take it as homework, try to find sequence of pentagonal numbers, hexagonal numbers, and so on.
So what's the meaning of that? So
So like for example, in this case, you represent numbers in a triangular shape. Here you represent numbers in square shape. Similarly, you express numbers in pentagonal shape. So like for example, first number is always 1. Then you extend it this way. 1, 2, 3, 4.
hexagon, that's hexagon.
Extra number. So this was pentagonal. Yeah. So 1 plus 4, 5, plus again you extend it. Similarly, you can try to complete in hexagonal fashion, and those numbers are hexagonal numbers. Yeah, so that was about third problem, right? Fourth one. So that is 5 plus 10 plus 15. And by now you have idea of different techniques. So let's complete it by one technique. And you check
Yeah, so
that,
this part, yeah, exactly, yeah.
right? But anyways, there are different ways to look at same problem. Because now we are
There are 4 times 1 plus 2 plus 3 plus 4 plus 5 plus till 25.
which
You
one?
can do that 4 times. So first
Yeah.
write 4 and then put a bracket, and inside that you can write from 1 till 25.
Yes, yes. Yeah. So this is now 20 into 21 by 2. 2 ones are 2 tens are. So it is 5 into 210. And that is 1.
Sir, we can also write it as 1 plus 2 plus 3 plus 4 plus 5 in the bracket, and outside we can write 20 as it will be easier.
Why you can write 20 outside?
Sir, because 25 is 100, right? That's why.
But we can't take 20 common from all numbers. We can take 5 common at most from all numbers.
Oh.
Right?
Yes, sir.
Okay. Now that last one, fifth one. Again, there are different techniques, but I'll show you one standard common technique which is useful, particularly while solving.
Yeah, so 1 till 100, and then wait, so 1 till 100 minus 1 till 50.
Very good. Yeah. So we have formula for 1 to n, and here the numbers begin at 51. So what I'll do is add 1, 2, 3 up to 50 and subtract 1, 2, 3 up to 50. All of you agree? So you give someone some money and take it back. So that person is left with same sum. जितना देते उतना वापस ले, right? So give 1 plus 2 plus 50, take it back, and the money is same, answer is same. But now this first bracket is 1 to 100, and I can use formula 100 into 101 by 2, and the second part is 1 to 50. So I'll subtract that 50 into 51 by 2. So guys, I guess already some of you have written the answer. Answer is 3775, right? Take your answers.
I couldn't understand.
Yes, so see
I
that.
didn't understand what you did for the
Okay,
fifth
okay,
sum.
yeah, I'll explain. So instead of this, let's take smaller problem. Suppose we are given 3 plus 4 plus 5. Now, our formula is for 1 plus 2 plus 1 up to 5, right? So what I'll do is, just for convenience, I'll add first two terms. But why extra? Why to add extra terms? I subtract them again. So essentially my answer is same. 3 plus 4 plus 5. I'm adding 1 and 2 for convenience and subtracting again. So it's like jitna de utna wapas le, right?
Sir, I think the question was 51 plus 52 plus 53.
Yeah,
till
yeah. So I'm explaining this idea with some small example. Same idea I'm using there. Add 1 to 50, subtract 1 to 50. And why add 1 to 50? Because I can use formula for 1 plus 2 plus 3 plus up to 50, 51, so on up to 100, right?
Thank you, sir.
Okay, so no doubt now?
No, sir, I got it.
Okay, yeah. And of course, there is one more technique. Instead, what I can do is, instead of this adding, subtracting, what I can do is (51, 52, 53 up to 100). So I'll take out 50 common, 50 plus 1. So break the numbers. That's the idea. 50 plus 2, 50 plus 3, and so on. If 100 I write as what? 50 plus 50, right? So I'll get 50, 50, 50. How many times? 50 times. 50 times, right? And plus I get 1 plus 2 plus 1 up to 50. So that is 50 into 51 by. So this is 2500 plus 25 say 1275. Now that is 3775.
So 50 multiplied by 50 is nothing but that one till 100. Oh no, I'm wrong. I'm sorry.
It's 50 square, 50 square. Yeah. So far, okay?
Yes, another way, yeah.
Now we'll actually go to the precise definition of AP. So far, we have done some relevant work, and that's useful for actual formulas in AP. So let's see what is AP. In fact, this 1 plus 2 plus 1 up to n, that is special case of AP. So let's look at real life example of AP. Say for example, now what is today's date? What's today? Thursday. So suppose I look at say 6th April 6th April was Thursday. And if I ask you what will be next Thursday to that, what you will tell me? Which is next?
37th April,
so-
Friday.
No, I'm asking 6th
What
April.
will be the next 30th, 13th?
13th April will be next Thursday. All of you agree?
Yes, sir.
Yes,
Sir,
What will be next Thursday?
20th
20th April.
20th
Oh,
20 April.
okay. So to add all the like the numbers in that column.
7th.
Sir, because 1 week is equal to 7 days, so we should add 7, 7, 7.
Exactly.
Yes.
Exactly. That is the idea of AP. So in AP, what we have is a sequence where we keep on adding common term. Okay. So suppose my first term is A. I'm calling it A, the initial term. Then I add some common difference. So A plus D. Next term will be A plus D
A plus
plus D. That is A plus 2D. Next
A
term will
plus 3. A plus 3D.
yeah, A plus 3D. Next term will be A plus
A plus
4D,
4D.
and so on. So such a sequence is called as arithmetic progression. Arithmetic progression. So where terms are with the same difference, common difference. Okay, and we'll look at again the definition with the help of examples, because examples make it easy. So for example, our Thursday example was like A equal to 6. Next is 6 plus 7, 13. Next is that plus 7, 20. Next is that plus 7, 27. And of course, there are no dates in a month after 34 and so on, right? So we'll stop at 27.
Sir, I have another method. So
Huh?
for sir, like for suppose we are doing till A plus 5D, so we should group all the A's. Like there are 5 A's, so 5A at one side, and then D plus 2D plus 3D plus 4D plus 5D. We should group that in another side.
Right.
So it will be
So that is that you are telling for addition of terms, right?
yes, sir. Sir, after coming the value, we know that A is equal to 6 and D is equal to 7. So there are 5A, then 6 5s are 30, then there's 30A, and then the value of D will multiply, and at the last we'll add them together.
Right. Yeah. Very good. So let's say formula for nth term, and generally that is called as Tn of AP. So look at the pattern. First term we are calling as A. Second term is A plus D. Third term is A plus, I'll add one more D. So shall I say A plus 2D?
D.
Then fourth term is, I'll add one more D. So A plus 3D.
3D.
Is that correct?
Yes.
Now if I ask what will be 100 term?
A plus
A plus 99D.
A plus 99D. Everyone agrees?
Yes, sir.
Yeah. So now what?
Sir, I didn't
See,
understand
The
how.
second term A plus 1D.
Yeah, so look at the numbers and the pattern. So second term is A plus D. Third term is A plus 2D. Fourth term is A plus 3D. So number there is one less.
So therefore nth term is A plus
100 term will be
1D.
100 term will be A plus
99D.
99. One less,
Yes.
right? So nth term will be A plus
99D.
no nth term.
Oh.
A plus
N minus 1. Sir, N minus 1 terms are there.
Minus 1.
that is formula for Tn.
We
Okay.
have done that in algebra in school.
In which standard?
Or 7th.
Oh, acha. Okay. So that must be CBSE.
No,
Alright.
sir, actually in 6th we did, but now my 7th started. That's why.
But I think that must be either CBSE or ICSE.
ICSE, sir.
Because usually in SSC schools, they don't have these things.
Yes, sir.
So, but I've learned this in sixth grade.
If you learn on your own, it's fine. But otherwise, generally in school syllabus, it's only for CBSE or ICSE, not for SSC. Okay, so this is nth term of AP,
But IB.
and somebody was already talking of the sum of n terms. So I'll call it Sn. And what do I mean by Sn?
Sir, right there, yeah. I was
First
talking.
term, first term, second term, third term, up to nth term. And you work like Gauss sum. I'll directly give the formula because we don't have much time now. So the formula turns out to be NA. So take all A's together. So we have n A's, and the other part by Gauss formula turns out to be n into n minus 1 by 2 times D, the difference. Okay. So I'm not proving, but you try to prove it on your own, like Gauss. Okay. So for the timing, we'll assume this
Sir.
formula. Huh?
Sir, was n plus, sir, was n multiplied by n plus 1 divided by 2 was the only formula made by Gauss, or are there more formulas made by?
No, Gauss worked a lot in mathematics. He worked really a lot. And all those concepts were his original concepts. So as rightly he's called Prince of Mathematics. In fact,
Sir, but why didn't people call Aryabhatta and those Indian mathematicians as Prince of Mathematics, even though they did this all before him?
yeah, but see, actually, it's more about the history because Europeans ruled the world for many years and they wrote the history. So wrongly, it's attributed to these people. So
Oh.
That's why Archimedes was more famous than Aryabhatta.
yeah, so for example, like Gauss was not the first one to use that formula or technique. So it was already known to Chinese as well as Indians.
But sir, then Chinese were like well known for their selves. Then like
No, even Chinese maths is very well like in Indian mathematics. So it's old as well as classic. And
So Chinese people start to learn math from a very small age.
yeah,
So when my father said that after in the INMO and all these things, when they get selected, mostly the people will be Chinese people, Japanese people. like
yeah,
that.
and
Yeah.
they are very much hardworking. In fact, their schools are 9 to 4, and right from 5 to 8, either they are into some gymnast or
badminton, sir.
or TT or like this maths or science,
So
whatever.
badminton, because like
Yeah.
it is also well known for badminton.
Okay, so let's again do some simple sequences of AP. And yeah, so let's come back to again this problem. 1 or 1, 3, 5, 7 and so on. So is it AP?
Yes, sir.
Yes, sir.
What is first
Arithmetic
term
progression.
and what
A
is
is
A
first term is 1. D
Yeah.
is 2.
2.
very good? Yeah. So sequence of odd numbers is AP. All of you agree?
Yes, sir.
And what will be nth odd number?
Sir, it will be
So
D.
we'll use formula for Tn, right? What is Tn? Dn is a plus n minus 1d. So a is 1 and 2 times n minus 1. Right?
Yes, sir.
Is 1 plus 2n minus 2. So if you simplify, it is 2n minus 1. So check, when I go on putting values of n, I get different odd numbers. N equal to 1, first odd number. N equal to 2, second odd number. N equal to 3, third odd number, and so on. Check. Okay. And the main point is sum of odd numbers, because that was something nice. So sum of n odd numbers, 1 plus 3 plus 5 plus so on up to nth odd number is 2n minus 1. So that is equal to Sn, right? And what is formula for Sn? Sn is
And
N
square, sir. You
N
also
A?
usually proved it, sir. You also visually proved it. And square.
Yes. So our answer was n square, right? But let's check it by formula for Sn. So it's n times a plus n into n minus 1 by 2 times d. So n times 1 plus n minus 1 by 2 times 2, these two. So these two cancels. So what I get is n plus, this is n square minus n, right? Right? N into n minus 1 is n into n minus 1 is n square minus n. All of you agree?
Yes, sir.
Yeah.
N into n is n square minus n into 1 is n, right?
How will it be n square minus
Wait.
n, sir?
So, no. So, n into n. Oh, yeah. Yes.
Yeah. So now,
Sir, how will it be n square minus n, sir?
just a minute. Just a minute.
No, if you expand it, n into n minus 1 is n into n minus n into 1, which is n square minus 1.
Just a minute. We'll go back to this formula for Sn. And I'm putting a equal to 1, d equal to 2 there, right? A equal to 1, d equal to 2. So what I get is 2 and 2 cancel. So n plus n into n minus 1. And n into n minus 1 is this much. So n and minus n cancel, and therefore answer turns out to be n squared as expected, right? So this is proof that why sum of odd numbers turns out to be n squared. Good. So I'll give some simple problems for practice, and we'll stop then for today. And tomorrow we'll continue with GP. Tomorrow will be our last session for this workshop. Yeah. So find the missing terms in AP. So it's already given that it's AP. You have to find the missing terms.
Chat box we write, right? In chat box you have to write, right?
No, this is homework. Now we don't have much time. So this is homework. So you practice it at home. 4, 9, 14, 19. So very first thing, is it AP?
Yes, sir.
Yes, sir.
What is
Sir,
E?
because we can find it in the question, because you wrote in the question that find missing terms in AP.
Yeah, but have I given correctly? What is A?
4.
4. And what is D?
Sir, it is 4.
And what is
Sir,
D?
D is 9.
Find the missing terms in
Sir, D is 3.
D is five.
Sir,
five.
D is 5 or 3.
D is 5. So you have to find these 3 next terms. Okay. One more. 88 missing. 112 missing. 136. 148 missing.
Sir, this this A is equal to 4, D is equal to 5. Can we use it to all these problems?
No, for second problem, your A and D will be different.
Yes.
So these are 3 different problems. Now for third one, first term is missing. Second is 215. Third is missing. Fourth is missing. 620. 755. Then, so I can call this as problem 1, 3 parts. Problem 2. What is 101st term? Of AP? 4, 10, 16, 22, and so on. One more.
Wait, so for the first one, all the answers which I know itself.
I couldn't hear. Just say it again.
So the first I wrote the answer in the chat. So like this.
Okay. You can put in chat box only to me.
I put.
Yes.
Sir, I had a question, sir. My internet had gone recently, so what is A is equal to 4 and D is equal to 5?
That is for first question. First term is 4 and the difference is 5. I'm not giving answers. This is homework actually. So you have to work on your own.
Okay, sir.
So we'll discuss it tomorrow.
Yeah. Tomorrow is 5th day and our workshop. It's last session of our workshop.
Yes, sir. So I think
But
we
if you are like this mathematics, hello, yes.
So second answer also sent in the chat.
Okay. Yeah. Yeah, but if you are like this mathematics, and then maybe later on you can join our year-long course that you can check on website.
Yes, sir.
Okay, one more question and I'll stop there. First term of AP. Is 3. Last term is 39. And sum of all terms is 210. Find the common difference.
So, but 39 and 3 are odd numbers.
So maybe perhaps common difference could be even some fraction or in decimals.
Yes, sir.
Find common difference D and the number of terms. Yeah. So with that, we'll stop for today and I'll continue with GP tomorrow. do read all these things once again and try to solve these problems, because this is something.
Wait, sir.
important.
This. Okay, sir.
Yeah.
No, it's fine. It's
Okay, bye. Good night.
Bye, sir. Thank you,
Bye,
sir.
sir. Thank you, sir.
Thank you, sir. Good night, sir.
okay, sir. I'm on the last